אני עכשיו, יש לי את הכבוד להזמין את דוקטור שרון מרקין, שהיא עוד חברה בצוות המנהל של המכון, ושרון היא חוקרת בכירה במכון גרטנר לחקר האפידמיולוגיה ומדיניות בריאות, והיא גם associate professor ב-UCLA, והיא תציג לנו גם אחר כך את המרצאה הבאה, וביחד עם פרופסור תרזה סימן תדבר על מעבר לביולוגיה, כיצד הסביבה החברתית משפיעה על ההזדקנות. שרון.
תודה רבה. I'm actually switching back to English, so today you're going to have your brain has to work hard. First of all, I wanted to thank Racheli Denkner and Lior in Racheli on her vision and leadership in this center and this conference today. Lior on thinking of all the details, and for the other members of the steering committee, it was a pleasure and honor to work with you. So I'm going to be actually just doing about 10 minutes of a brief introduction to the concept of social epidemiology. So a lot of epidemiologists joke that since the COVID pandemic, we no longer have to explain to people what an epidemiologist is, but I feel I still have to explain what social epidemiology is, because not everybody knows that. And I'm going to be introducing Professor Teresa Seeman, who will join us virtually. She will be presenting a lot of the research that she has led and that we work on together. And so I'm going to be setting up the framework by introducing the concept of social epidemiology, a bit about the history. So I'm going to start with a bit of personal history. In 2003, when I received my doctoral degree at Johns Hopkins University, social epidemiology was a very young field, and I was coming from cardiovascular disease research world, where a lot of epidemiologists were not taking social factors very seriously in this regard. And I was lucky enough fortunate to have as my mentor one of the leaders in this field, Professor Anna Diaz-Rue, who was at Columbia University at the time. And when she heard I was returning to Los Angeles, she said, "You must contact Professor Teresa Seeman." And since then, we've really developed, for over 20 years, a very collaborative research relationship. She's been my mentor, and we've worked together. We've developed a friendship, and I'm very, very honored to introduce her today. And as I do that, I will give you a little bit of a history of social epidemiology. So for over about 200 years, it's been acknowledged and known and reported that there is a relationship between social factors, primarily poverty, and the increased prevalence of disease. What has changed over time is the explanation of the role of social factors. So in very early days, there was a focus on the individual, let's say poor individual, having some kind of intrinsic flaw or fault or immorality even, or destiny in basically being at risk for disease. In about the 1850s, along with the famous father of epidemiology, John Snow, there were other public health activists, namely a lesser-known German scientist and public health activist by the name of Rudolf Virchow, who said, no, let's start looking at societal flaws, societal problems, as generating these conditions that affect the individual's health. And with that came a lot of public health reform. And in fact, this public health reform really did lead to the plummeting of infectious disease death rates. That was a primary source of, a primary killer at the times. And improved sanitation, clean water supply, the introduction of antibiotics, vaccinations, led to these really plummeting death rates. And around the 1960s, we have recorded evidence that public health physicians and agencies expected health disparities to essentially disappear, because we've taken care of the societal conditions that produce these disparities, and so there shouldn't be any more differences between different population groups based on their social context. But we ended up seeing something very different. Here you see overall death rates in a sample of the white population in the US In 1960, you see a difference between the top two bars are men, low education, high education. The bottom two bars are women of low and high education. And there's a difference in the death rates at a time where supposedly there shouldn't be any more disparities. And not only did that difference persist, but they've been amplified and widened. And I would say in most Western countries and generally worldwide, we see these disparities based on socioeconomic and other social conditions. And so the question is, what is the issue? Why is this persisting? A second important set of observations was in what's known as, famously in the social epidemiology world, the gradient, okay? So the original theory behind socioeconomic influence on health is one of a threshold effect, right? As soon as you give individuals or populations the basic resources they need, you should no longer see a difference between these different populations. But in fact, we don't see that. We see what would be considered a dose-response relationship, where every single like rung in the socioeconomic spectrum, let's say, is associated with increased health risk, right? So as we go to the lower socioeconomic status, we see increased health risks. And this is just an example of a variety of different health outcomes. So these two basic kind of observations led in the 1980s to a resurgence of this idea of like growing evidence of the fact that social determinants of health are an important consideration, and that these social factors are a bit deeper than what was thought of before. So famously, two researchers in this area, Bruce Link and Joe Fellin, coined the term the fundamental causes, that social determinants are fundamental causes of disease. Okay, so both the persisting disparities as well as the socioeconomic gradient led to the idea that we need to think about how social factors, as they say, get under the skin and affect biology. And that these factors are more of the root causes of disease. And the focus among social epidemiologists, this was really the kind of the foundation of this subfield of social epidemiology, that we have to not just look at proximate risk factors, we want to go more upstream and look at the conditions that produced or made those risk factors hold. In terms of aging, while social epidemiology posits that we don't live in a vacuum, we live in our social context, our social identity, our conditions of life, we don't age in a vacuum, right? So the additional complication, I would say, of aging is that these various factors, biology, social factors, psychological factors, change drastically as we age, as do the conditions in which we live. So this complicates, from a research perspective, the teasing out of social factors and what you would perhaps call normative aging factors. And this is where Professor Seeman and her research and the research she has led and the research we've worked on together has been very critical to our understanding of the interplay between social determinants of health in impacting biological aging. And I'm just going to highlight kind of the main highlights, and she'll be talking about a bit more of these details. So this research centers on thinking about biological aging as a multi-system process, not focusing on one biological system or one at a time in terms of risk factors, but thinking about this as overall wear and tear on the body, otherwise known as allostatic load, a concept she'll introduce. And not only has this research tested this theory, but also thought about how to measure allostatic load. A second very important finding was that, again and again, we see that social factors in middle-aged adults, actually we've also looked at young adults, middle-aged adults, and older adult cohorts, social factors often precede these allostatic load or overload measures. And so one way to think about it is that the social factors accelerate this process. The negative social factors accelerate this process. The positive social factors we have found actually slow down this aging process. And of course that these factors shift over time. And I'll add that what has been important, I think, about some of the research that Teresa has led in particular has been the focus not only on these traditional measures of social factors such as socioeconomic status, income, and education, but a focus also on social integration, social support, and less commonly used and considered factors that are especially relevant to older adults. And finally, and I think what's been very inspiring about Teresa's leadership in this area is that she has taken a lot of her research and applied it to programming and to a very exciting study called the Generation Exchange Study that she'll be talking a little bit more about, that has really taken her research and applied it to bettering the lives of older adults. So just on a final note, I will say that Teresa did hope to be here, but she, for very good reason, she did not come, because she is receiving the Osterwell Award for Innovation in Geriatric Medicine this week at UCLA at the Geriatrics intensive course that they wanted me to say you're all welcome to. It's a virtual meeting, and I'm happy to share that information with you. She has graciously provided us with a recording of her lecture, and I'm also available during the break for any questions or comments or anything you want to pass on to her. So with that, I will introduce the next talk. Thank you.
Thank you for the invitation to participate in this inaugural CUNICA conference. I wish I could have arranged to be there in person. As I will discuss at the end of this presentation, my current research is focused on a program that recruits and trains older adults to work as tutors and mentors in elementary schools in the Los Angeles area. And we're in the midst of training for our latest recruits who will enter the schools next week. Before I begin my presentation, I also want to acknowledge the central role that Dr. Sharon Merkin has played in much of this research. She has been a valued colleague and friend for over 20 years, and I still miss seeing her in person at UCLA. But thankfully, we've been able to continue our weekly working sessions via Zoom, and I hope to be able to visit Israel soon for some more in-person collaborative time. Hello, my name is Teresa Seeman. I am a professor on the faculty in the Division of Geriatrics at UCLA. I'm honored to be asked to present at this conference. My background is as a social epidemiologist, so not a clinician, and most of my work focuses, as my presentation and its title suggest, on examining how social aspects of our lives influence health and aging. All right, well, as I said, the focus of my presentation is on better understanding why we see different trajectories of aging, and in particular, my interest has been in how our interactions with our external worlds, and most specifically, how our social and psychological experiences may impact health and functioning over the life course. So in today's presentations, I've sought to take you along on my own journey from classic epidemiology. I began my career looking at how social factors might affect major health outcomes, to a more in-depth focus on understanding the biological pathways that might explain those relationships, and finally to my most recent focus on developing a program that seeks to enhance social and psychological health as a means of fostering greater resilience in health at older ages. As this slide reminds us, we've evolved animals, and as such, a majority of us are quite aware of and sensitive to the others in our environment, what they say and do, and how that impacts or might impact on us. And given this evolutionary history, it's plausible to hypothesize that our relationships with others, our social worlds, may have significant effects on us physiologically. As my own earlier research and that of other epidemiologists has demonstrated, those of lower socioeconomic status and those with fewer social relationships and/or whose relationships are characterized by conflict or an inability or unwillingness to provide assistance when it might be needed are more likely to experience a range of poor health outcomes, including increased morbidity, increased risk for cognitive and physical impairment, and increased mortality. My shift to focusing on documenting the actual biological pathways linking these social influences to downstream health outcomes was largely driven both by my own intrinsic interest in knowing what those pathways might be, but also importantly as a means of showing colleagues who were skeptical that social factors were causally related to health outcomes, the actual pathways linking social experience to major health outcomes. As I became interested in exploring biological pathways, I had the immense good fortune to meet Bruce McEwen, a neuroscientist who became a mentor, a colleague, and an extremely good friend. At the time I met Bruce, he was beginning to outline a new concept that he called allostatic load. This concept highlighted the importance of taking a multi-systems view of the ways in which our life experiences impact multiple biological regulatory systems and how, over time, the demands on those systems as we seek to adapt to the stimuli in our lives can result in wear and tear on those regulatory systems, resulting in dysregulations that contribute to elevated risks for morbidity and mortality. The concept of allostatic load built on the idea of adaptive allostasis. As shown here, adaptive allostasis focuses on the idea that regulatory systems, as shown on the vertical axis, including systems that regulate blood pressure, glucose, and stress hormones such as cortisol, are designed to respond to stimuli as we seek to adapt to our environment. And once the response is complete, the system turns off. As shown by this second graph, the concept of allostatic load highlights two types of changes to regulatory systems that frequently occur as we age, as our regulatory systems experience wear and tear over time and may become dysregulated. First, as shown here, a system may no longer be able to maintain itself at the desired baseline or resting level. For example, with age, we tend to see that people's resting blood pressure is higher. A second feature we see as a system becomes less adaptive and efficient is an inability to efficiently turn off a response once it's been initiated. So a prolonged period of heightened activity is evident once the system is stimulated. This slide illustrates this pattern of age-related wear and tear, showing cortisol responses to a driving simulation challenge. Younger and older adults sat in a simulator, and they were asked to drive and respond to sudden challenges, like a car suddenly cutting in front or stopping in front of you, or someone opening a parked car's door in your path. As shown by the yellow and red graphs, among younger adults in their 30s and 40s, the HPA axis responds with increased cortisol during the challenge, from 0 to 45 minutes, and then shuts off. However, among those aged 70 and older, the green line, as you can see, the system is able to respond, but has trouble shutting itself off after the challenge is over at 45 minutes. This next slide shows a similar pattern of impairment in system efficiency in terms of response to a standard glucose tolerance test. As can be seen, in comparison to the youngest age group, those aged 65 plus exhibit a prolonged pattern of stimulation, the system being unable to turn itself off as efficiently as is possible at younger ages. The multi-systems perspective on health risks that the concept of allostatic load offered struck me as particularly relevant with respect to how external social factors likely impact health outcomes. That is, rather than only affecting blood pressure or glucose, our experiences are transduced by the brain, resulting in alterations in multiple biological regulatory systems, including primary regulatory systems such as the autonomic nervous system and the HPA axis, and secondary regulatory parameters, including cardiovascular, metabolic, and immune parameters. As a result, simply looking at individual biological parameters would not be the most appropriate or best way to assess the overall impact of our social or psychological factors on our internal physiological milieu. One of the first ways in which we examined the hypothesis that social factors simultaneously impact multiple biological regulatory systems was to look at the patterning of biology by socioeconomic status. SES is perhaps the major social determinant of the context in which we live, something that impacts pretty much everything about our daily life, including what our physical world is like, what challenges or stimuli we face, and what resources we likely have with which to address those challenges. Using data from the US National NHANES surveys, we looked at whether and how a range of biological parameters all known to impact health risks, were patterned by SES. Here we show SES gradients in higher risk values for multiple known biological risk factors using education as our marker of SES. As noted along the horizontal axis, cut points for higher risk values are largely defined by known clinical risk levels. The bars of the graph indicate the percent of individuals in the different education groups who have values at or above that cut point. As you can see, those with the least education, the red bars, have the highest percent of individuals with these higher risk values for nearly all of these biological parameters, with steadily decreasing percentages of individuals with such high risk values as you go from lower to higher education groups. This next slide shows just how early in life these SES gradients are evident. I was personally shocked to see these SES gradients even among 1 to 5-year-olds. Here we're showing the percent of kids with the highest glycohemoglobin levels, defined as values in the top quartile of the distribution within each of the 4 designated age groups. Here we used poverty-income ratio as our marker of SES. This ratio indicates how the family income compares to the poverty level for a family of that size as defined by the census. So higher ratios indicate those with higher family incomes. As seen among 1 to 5-year-olds on the far left, as well as in each of the other age groups, the children with glycohemoglobin values in the top quartile of their age group are more likely to be those living in lower income families, the poorest families, shown in the red bars, with decreasing percentages of children with high values seen as we move to the right toward children living in higher income families. Like the glucose data, here we see similar patterning of income for primary stress hormones, cortisol as a marker of HPA axis, and epinephrine and norepinephrine as indices of sympathetic nervous system activity. These data come from a study by Gary Evans comparing overnight urine levels of these stress hormones for children living in poverty versus children from more middle income families. Again, we see among these 8 to 10-year-olds that already there are significant differences in the extent to which the HPA axis and the sympathetic nervous system are able to shut off overnight. As this next slide shows, we find similar patterning in midlife with data on 32 to 45-year-olds from the coronary artery risk development in young adults, the CARDIA study, clearly suggesting the persistence of these socioeconomic differences over the life course. Given the time constraints today, I'm not showing the data, but we also see the persistence of this same social patterning of HPA and sympathetic nervous system dysregulation among older adults aged 70 and over. Given these clear and consistent socioeconomic gradients in biological risk across multiple major parameters, we sought to move beyond looking at individual parameters and to take a multi-systems view of cumulative biological risks by creating a multi-systems index of allostatic load and then assessing its association with subsequent health outcomes over time. Our first attempt at operationalizing allostatic load, we used data from the MacArthur Study of Successful Aging, a study I was helping to run at the time. The MacArthur study was designed as a longitudinal cohort study where we selected adults aged 70 to 79 from ongoing cohort studies of aging in 3 cities in the US, Durham, North Carolina, New Haven, Connecticut, and East Boston, Massachusetts, shown in the top box here. As noted in the middle box, we selected adults aged 70 to 79 who represented those in the top third of that age group with respect to physical and cognitive functioning in order to create a cohort we could follow over time to assess factors associated with more successful aging. In our initial effort to create a measure of allostatic load, data from the MacArthur study provided assessments of the regulatory systems listed in the left-hand column here. The right-hand column lists the specific parameters for which we had data. For example, for the cardiovascular system, we had resting systolic and diastolic blood pressure. For the sympathetic nervous system, we had overnight urinary norepinephrine and epinephrine. We also had measures of inflammation, lung function, and renal function. For our initial operationalization of allostatic load, we simply calculated for each subject the number of these different parameters for which they had a value that placed them in the highest risk quartile within our MacArthur cohort. Here we see the distribution of our allostatic load score within the high-functioning MacArthur cohort. When we compare this distribution to that of more medium and low-functioning subgroups within the original aging cohorts from which the MacArthur high-function group had been chosen, we see that the allostatic load scores are shifted towards higher scores for these lower-functioning groups. We also looked at allostatic load scores within the National and Haynes sample, where we could examine a wider range of age groups. As we looked at allostatic load distributions for progressively older age groups, you can see that the green bars showing the lowest allostatic load scores begin dropping as smaller percentages of the older age groups have these lowest scores, while the yellow and especially the red bars indicating the highest allostatic load increase. With our new measure of allostatic load, our next focus was to examine the hypothesized links between levels of allostatic load and subsequent health consequences. This slide shows data from the MacArthur study looking at the relationship between baseline allostatic load to subsequent mortality. As you can see, higher levels of baseline allostatic load were associated with increasing risks for mortality over the next 7 years in our cohort of high-functioning 70-year-olds. We also examined other health outcomes in the MacArthur cohort, finding significant relationships between higher allostatic load and subsequent incident cardiovascular disease, as well as declines in physical and cognitive performance. We've also documented health consequences of higher allostatic load in other major US cohorts, including the NHANES in terms of higher mortality, the Midlife in the US or MIDAS study with respect to greater mortality and declines in cognition, and in the multi-ethnic study of atherosclerosis, the MESA study, with respect to greater mortality and incident cardiovascular disease. As I noted at the beginning of my presentation, in addition to social status or socioeconomic status, the quantity and quality of our social relationships is another aspect of our social worlds that's been a focus of my research in terms of their potential impacts on health and aging. In early research, as I mentioned, we documented links between greater social integration, more social ties, and lower mortality risks, as well as associations with less coronary artery disease. And others have shown relationships to better immune function and cognition. So I was curious to see if those relationships were mediated by links between social relationships and biological aging using our measure of allostatic load. This slide summarizes data from a study we did using data from the Cardia study. We created our index of allostatic load parallel to how we did it for the earlier MacArthur study, counting the number of parameters for which the individual had values in the top risk quartiles of each biological distribution. As shown here, going from left to right, when we look at average allostatic load scores by 3 aspects of social relationships: number of reported social ties, levels of reported emotional support, that is how often your social ties make you feel loved and cared for, and levels of social conflict, how often others are critical of you or place too many demands on you. For social ties, the bars on the far left, those with the fewest ties, the red bar, have higher allostatic load on average, with decreasing levels of allostatic load as we look at groups reporting more social ties. Similarly, as reported levels of emotional support increase, the set of bars in the middle, the average levels of allostatic load decrease. Significantly, we see the opposite pattern with respect to social conflict, another feature of our social relationships that has traditionally received much less attention with respect to its potential impacts on our health and well-being. As shown in the set of bars to the far right, those reporting greater social conflict in their social relationships have significantly greater average allostatic load. Most recently, I've focused my work on efforts to turn data and evidence from this earlier work of mine and others regarding the benefits of social engagement and maintaining a purpose in life, as well as the benefits of cognitive stimulation and physical activity, into action through a program called Generation Exchange. The Generation Exchange program seeks to foster resilience through intergenerational relationships in win-win arrangements, leveraging the reservoir of talent, experience, and commitment available from older adults to address unmet needs and create greater social good, bringing together adults age 50 and older with children in kindergarten through 5th grade to create better health outcomes for Gen X adults and better education for the children. The program goals include creating high-impact generative roles that will be attractive to older adults, incorporating health promotion elements through increased social, cognitive, and physical activity, with social engagement through working in teams and in classrooms, and roles that incorporate cognitive and physical stimuli. And to demonstrate that such programs on a larger scale could have large societal benefits, enhancing public education, and demonstrating the benefits of an aging society. Our generation exchange model recruits adults 50 and older to serve in public elementary schools. We ensure that they're taking on meaningful roles, including tutoring and mentoring, and fulfilling important needs in the school, not filing papers or grading papers. We incorporate a high-intensity dose by asking for a commitment of 10 hours per week, and we put a critical mass of adults in each school with teams of 10 or more per school. There's a sustained dose. People are in the schools for the full school year, and health promotion via physical, social, and cognitive activity, and psychologically and emotionally fulfilling activity. We do have some preliminary evidence from 1 year of generation exchange, comparing measures of health from the beginning of the year prior to engagement with the program to the end of that academic year after 9 months working in the classrooms. We found some evidence of reductions in blood pressure, as well as improvements in the speed with which our older adults could complete 5 chair stands without using their hands, and how quickly they could complete a 4-meter walk. We've also completed a small pilot where we found changes in gene expression from pre to post Gen X engagement, with reductions in pro-inflammatory activity as seen in the bars on the left, and increases in antiviral activity as seen in bars on the right. We're actually now running a formal randomized trial with funding from the National Institute on Aging to test this finding more formally. We've also seen increases in social engagement, with 100% of our participants reporting making new friends by the end of 1 year, and 40% telling us they meet with other team members outside of school. We've also seen improvements in psychological well-being. Again, everyone reports an improved sense of well-being and that they're doing something important and contributing to the kids' success. Although this presentation is focused on our impacts on the older adult Gen X team members, I think it's important to also highlight the intergenerational impacts of this program. For students we engage with in the classroom, teachers are reporting declines in office referrals, improvements in attendance, improvements in classroom engagement and behavior, and perhaps most importantly, improvements in literacy skills with improved letter recognition, sounding out of words, and reading, depending on which grade level we're looking at from K through 5th grade. In summary, in this presentation, I hope I've been able to highlight the ways in which we find evidence that better health and aging are linked to social influences in terms of higher social status, greater social integration, greater social support, and less social conflict, and that those social influences appear to be mediated via multiple biological pathways, with the concept of allostatic load providing a perspective that focuses on cumulative impacts of these biological effects of social factors and the resulting differentials in health outcomes. And finally, that programs like our Generation Exchange program offer an example of intergenerational win-win interventions. For older adults, we find preliminary evidence of potential health benefits. For the school children, academic and socio-emotional benefits. And for the teachers, a third generation who we hadn't explicitly targeted when we were developing the program, we see greater apparent retention of new teachers, with a number of principals reporting that they think some of their newer teachers would not have made it through the year if not for the presence of the additional Gen X adult in the classroom, and overwhelming reports from teachers about how much they appreciate and benefit from having a Gen Xer in their classroom. And finally, I want to acknowledge all of my wonderful colleagues and collaborators who contributed to all the work that I've outlined here, with a special thank you to Arun Karlamangla and Sharon Merkin, who've been UCLA colleagues and collaborators for over 20 years, as well as thanks to the larger interdisciplinary team of collaborators who've contributed to this work. And finally, a special thanks to all the participants in the studies I've discussed, without whom none of these data would have been available, and to the Generation Exchange staff and volunteers who ensure that I continue to be socially engaged in something that's rewarding and fun as I pursue my career here at UCLA. Thank you very much.
תודה רבה לדוקטור מרקין ולדוקטור סימן על הרצאות מאלפות. אני חושבת שאנחנו רואים איך הכל מתחבר, הכל קשור להכל, והיוזמה הזאת שהציגה לנו דוקטור סימן היא מתקשרת יפה ל-84, שפרופסור מערבי הוביל אותה בארץ, אז זה באמת יפה לראות, ואני חושבת שזה גם שולח אותנו להפסקת הקפה של רבע שעה עם הרבה מחשבות ועוד הזדמנות לדבר בינינו, ואני מבקשת מכולם, אם אתם יכולים להירשם בשולחנות העגולים, שמנו לכם את הניירות בחוץ כאן, אז תצוותו את עצמכם לשולחן עגול אחד מהשלושה, ונתכנס כאן בחזרה ב12:45.